it is not permissible to use SCR cable to feed a 240 delta 3-phase subpanel in a commercial application. SCR cable, which stands for Service Entrance Cable, is typically designed and approved for use as the main feeder from the utility service entrance to the main disconnect of a residential dwelling. Its construction and insulation properties are generally intended for the load characteristics and environmental conditions found in residential settings. In a commercial application utilizing a 240 delta 3-phase system, several factors make SCR cable unsuitable. Firstly, commercial electrical systems often demand higher current carrying capacities than those typically encountered in residential setups. The conductors within SCR cable might not be adequately sized to handle the continuous load requirements of a commercial environment, especially with a 3-phase system where the current is distributed across 3 hot legs. Overloading the conductors can lead to overheating, insulation breakdown, and potentially fire hazards. Secondly, the insulation used in SCR cable might not be rated for the higher operating temperatures that could occur in commercial electrical systems. Commercial environments often have more demanding thermal conditions due to heavier equipment usage, increased ambient temperatures, and the potential for harmonics which can exacerbate heat generation in conductors and equipment. Thirdly, commercial electrical installations are governed by stricter codes and regulations compared to residential installations. These regulations often specify the types of wiring methods and insulation required for different applications to ensure safety and reliability. SCR cable might not meet the specific requirements for use as a feeder to a subpanel in a commercial setting, particularly when dealing with a 3-phase system. Furthermore, the grounding requirements for commercial 3-phase systems are more stringent than those for residential systems. SCR cable typically includes a neutral conductor that is also used for grounding purposes, which is acceptable in some residential applications. However, in a commercial setting, it is generally required to have a separate equipment grounding conductor to ensure a low impedance path for fault currents, thereby minimizing the risk of electric shock and equipment damage. The NEC, or National Electrical Code, provides detailed guidelines on acceptable wiring methods and grounding practices for different types of electrical installations. Consulting the relevant sections of the NEC, such as Article 250 concerning grounding and bonding and Article 310 concerning conductor ampacity, will provide clarity on the specific requirements for your installation. It is also crucial to adhere to local electrical codes and regulations, as these may have additional requirements or restrictions beyond those specified in the NEC. When selecting wiring methods for a commercial 240 delta 3-phase subpanel, consider alternatives such as THHN or XHHW conductors installed in conduit. These conductors have higher temperature ratings and are available in a wider range of sizes to accommodate the current carrying requirements of commercial loads. Conduit provides physical protection for the conductors and allows for future modifications or upgrades to the electrical system. Additionally, ensure that the equipment grounding conductor is properly sized and installed in accordance with the NEC to provide a reliable ground fault path. To determine the appropriate conductor size for your application, calculate the expected load on the subpanel and consult NEC Table 310.15b16 for allowable ampacities of insulated conductors. Consider factors such as ambient temperature, conductor bundling, and voltage drop when selecting the conductor size. Voltage drop should be limited to a maximum of 3% to ensure proper equipment operation and prevent overheating of conductors. When installing the wiring, follow best practices for terminating conductors and making connections. Use appropriately rated connectors and ensure that all connections are tight and secure. Improperly made connections can cause overheating, voltage drop, and potentially arc faults, which can lead to fires. Always consult with a qualified electrical engineer or licensed electrician to ensure that your electrical installation complies with all applicable codes and regulations. They can provide guidance on selecting the appropriate wiring methods, conductor sizes, and overcurrent protection devices for your specific application. Attempting to perform electrical work without proper training and experience can be dangerous and may result in serious injury or property damage. In summary, While SER cable is suitable for certain residential applications, it is not an appropriate choice for feeding a 240 delta 3-phase subpanel in a commercial environment due to limitations in current carrying capacity, insulation temperature rating, and grounding requirements. Always adhere to the NEC and local electrical codes when selecting wiring methods for any electrical installation.